So let's get started. Right here. Okay, questions to start with. Anybody have specific questions? Okay, guys. Yes. No, you can have not have. You can have any question you want. Anything.
Could you do zinc dichromate?
Zinc dichromate. I don't think that you are required to know zinc or dichromate, but if you go to your sheet like here, you are being recorded right now. Okay, so you got zinc, which has a +2 charge, and dichromate is actually Cr2O7 -2. So, do our charges add up to 0? So it's just going to be putting them together. It should pop back on. I don't know, every so often it takes a breath. And so that's zinc dichromate. If you looked on your polyatomics, this is dichromate right here. Yep.
Can you do lead 2 bicarbonate?
Lead 2. Okay, this is a good question. It came up last hour too. Bicarbonate is not named technically there. So lead, and the Roman numeral tells you the charge. Bicarbonate is actually hydrogen carbonate ion, which is HCO3 -1. So, do we have enough hydrogen or bicarbonate ions there? No, you need another one. So, now you got 2 of these guys, so they have to go in parentheses. When I highlighted these on the board, I think I named it bicarbonate. So hydrogen carbonate and bicarbonate are the same thing. Well, bicarbonate's become the common name of hydrogen carbonate. So it's just the way they name things. If you look, carbonate is CO3 -2, right? And if I add a hydrogen to it, which is plus, I only add one hydrogen, then it becomes this. And through common usage, it's also become known as bicarbonate. And a lot of times in industry or whatever, they name something and it sticks out in the real world. Because sodium bicarbonate is baking soda. We don't know it as sodium hydrogen carbonate.
So if there was like a bichromate, does that mean there would be a hydrogen or no?
No, only the ones that we highlighted you have to know. Yeah, so, but bicarbonate is HC3O3 minus. Just know that. Okay, more guys. Yep. Silver iodide. Whoop. Now, IDE tells you that it's binary. So now we have silver and iodine. What is silver's charge? It was our SCAS. +1. What is iodine? -1. Do our charges add up? Mm-hmm.
Could you do like a couple of those circle ones?
Okay, I got some up here. Let's do nitric oxide. Now, this was off of the sheet from Monday. The problem here is we haven't really discussed what nitric is, and Alex here has NO. You're not going to end up with any of these, but one that he did put on here that is mercury to fluoride. All right. Symbol and charge on mercury 2. Here you go. Symbol and charge on mercury 2. Hg +2. Symbol and charge for fluorine. So what do we need? We need another fluorine. So what's the the formula? Yes, it's good. Let's go. Let's start with the binary and then we'll go to oxys, because we talked acids are one thing, binary acids, and Mr. Lasorsa calls them ternary acids, but I also call them oxy acids. Now, binary means you have two elements, right? In an acid, what is one of the elements all the time? Hydrogen plus one other. And it's always a nonmetal. Now, ternary acids have hydrogen, another element, and because they're oxy acids, all right, and oxygen. So ternary means 3, so you got 3 parts to it: hydrogen, oxygen, and one other thing. So let's do side-by-side examples here. And I will try to write neater here. So if I say, we'll go back and forth here. Let's go with H2S. Now, naming a binary acid, you start with hydro, then the first part of the second element, sulfur, and then you end in ic. So binaries start with hydro, end in ic, and acid. All right. Now, if I do H2SO4, this is totally different. It's going to sound the same, but these are two distinctly different acids. What is SO4 called? Sulfate, correct? And we said when you're dealing with acids, 8s then become ics, but no hydro. And this confused some people in third hour. You do not start ternary acids or oxyacids with the word hydro. This is just plain old sulfuric acid. Note the difference. We have hydrosulfuric here, which is a binary. We have a sulfuric acid, which is a tertiary or ternary acid, or an oxyacid. They sound similar, but they're totally different. Yep, Marcus? Now let's look at that. So if I have, let's go with phosphoric acid here. Okay, we said all acids start with hydrogen, and phosphoric started out as phosphate. All right, eights and ics are interchangeable. If you have a polyatomic that ends in 8, it becomes ic when you put it into an acid. So we have PO4 minus 3. How many hydrogens do we need total? We need 3 total to make a 0 sum. So then this becomes H3PO4. Okay, we have hydrofluoric acid. What does the hydro tell you? It's a binary acid, and it ends in ic. So, hydrofluoric is binary. One always has to be hydrogen. The next is fluorine. What's the charge on fluorine? So, what's the formula for hydrofluoric acid? HF.
I just had some Chinese stuff pop up on my screen. It was just a straight grade stream with black Chinese writing. Yeah. It said your computer restarted because of
Yep.
What are these organic chemistry things?
You don't have to do those. I put that in the notes, didn't I?
Mr. Pinilla, are we gonna have to know like thiosulfate?
No.
Because I have no clue what
All right, guys, a couple of them here. Hydrocarbonic acid. We got H and C, right? What is the charge on carbon? -4 in this case, because hydrogen's always positive. H4C. Now, we come over to carbonic acid. We know it's going to have hydrogen. X used to be 8. So, then you get H2CO3. But wait, there's more.
What is wrong with Spotify?
I think they blocked it.
Did they really? It's still in self-service. I wanted to.
Okay, let's look at this.
Wait, why'd you do O3?
CO3, because that's carbonate.
Oh.
Oh, there's a new update. That's why. Oh, you have to go install the new update. Look at he's using Spotify.
Okay, look here, guys. Look here, guys. HNO2. We know that it's an acid. Now, we have NO2. What is NO2? Nitrite. Ites become OUS. So this becomes nitrous acid. All right. Ites become OUS. Eights become ick.
It keeps telling me to type in an administrative password.
If you're not downloading it from.
He's an administrator.
He's not an administrator. He's a teacher.
Okay, here we go. Another one. Got two parts here. Acetate. All right, guys. Acetate. Eights become what? Ick. So this is acetic acid. This is also known as vinegar.
I guess I'm drinking acid.
Drink it every time you drink a pop.
What?
You drink it every time you drink a pop.
Or wait. Oh, wait. I drink vinegar too.
All right. Sounds like we're ready to take the test. Any more questions? Remember, we got binary ionic compounds. We have binary transition, which will trip everybody up unless you really know your Roman numerals. We have binary molecular. Then we have polyatomic compounds. Yep.
I'm just asking for a bit of clarification. Do we have to memorize all of these or just
Only the highlighted ones. All right. Now, I heard Mr. Nick ask, what's a binary ionic compound? These are metal, non-metal combinations. These are transition metals. Non-metal. These are non-metal combinations. And these are metal.
I never go on my email.
I have 0.
So, since you're all ready, let's do this. Yep. It'll be, I'll have to upload it to YouTube and then I'll link it so I can hear all your talking, or people can hear all your talking. So we're going to do this. Going to give you I'm going to put formulas down. You have to name them.
Make sure you start.
Okay, here you go. You're gonna have 20 of these tomorrow. So work these out. I'll give you 8 minutes. Actually, I'll give you 7 minutes.
He just got his headphones when I told him to listen to the song.
I gotta get some paper.
I will pause. Table 8. That's table 8. We got HBr. H tells you what?
Hydro, it's acid.
It's an acid. So you start it with hydro. What's Br?
Bromine.
So you go brom, and then you end it in
I.
ick.
Oh, ouch, yeah.
Ick. Acids end in ick. Binary ones. Table 2. 5 Musketeers. CAS.
Calcium sulfide.
Calcium sulfide. It's just a plain old binary compound. It's ionic. Table 4. That's Cisco's table. This is molecular. Molecular. It's diphosphorus pentoxide. It's molecular. They're both nonmetals. Table 5. Say it with confidence. Sulfuric
Sulfuric acid.
acid. Okay. Because this by itself is sulfate, and polyatomics, if they're 8s, they become X. Table 1. Aluminum oxide. You don't have to worry about anything other than the
Yeah, mine's almost one.
name.
I'm at 2 minutes 37 seconds.
Table 7. What'd you say? Aluminum sulfate. All right. Now, table 6 and 3, these are more complicated. So, we know that we have a copper, correct?
Oh, yeah.
And we know that we have 2 chlorines. What is the charge on chlorine?
99 cents.
Each chlorine? -1. So what does the charge on copper have to be? +2, but because it's a transition, you have to use the Roman numerals. It's copper 2 because on transition metals, you have to go out and ferret out the charge on the copper. And then table 3, iron's in the middle. It'd be iron 3. You are correct. Now, somebody goes, why is the 2 there? Here's the deal. You have 3 oxygens, right? They all have -2 charges. And you have 2 irons. Our total negatives are 6, so we need a total positive of +6, so each iron has to be +3.
Oh.
Now, Hannah asked a really good question. How do you know when you use the crossover? So let's look at what we just did. Iron +3, oxygen -2. But then I'm going to do something different. What are you looking for? All right. Now, so if they're odd and even, you can just use the crossover method. The 3 goes down here, the 2 goes here. It becomes Fe2O3 because the common number we can get between these two is 6. So if I have 2 irons, I need 3 oxygens. Now, here's what I said, if they're both even and one of them's a 2, you want the simplest whole number ratios. So, how many O2s do we need? 3.
I'm sorry.
So, if I were to divide by 2, that would be 3 to 1, and you could do this. So it's WO3. Even if it was like this, Hannah, if we had iron +3, chlorine -1, you can still do the crossover. So it's going to be FeCl3. All righty. Let's see if you can get through the names now.
Mr. Purdue,
Yeah.
how many weeks left do we have on this?
Probably about 5.
5 weeks to get 0.
No, 3 or 4, maybe 4 now. 3 or 4.
No, it's we like made a code for Spanish. So like use Spanish, but then it's in code so that no one understands it. Like, you know, it gives a code for Oh, yeah. Get that crap off our desk.
Okay, here you go. as soon as it comes back on the screen.
Eat it.
That's why you know they say do not eat donuts.
They don't want you to choke.
You open up one of those packets like they're
The Phillips gel packet.
I'm reading your
You know you did. What?
Okay, guys, you're gonna have 20 of these or more tomorrow. You got the name, you gotta write the formula. Record. Table 3, hydrochloric acid. HCl, just that simple. Because hydro tells you it's binary and it has chlorine in it. Table 6, ammonium phosphate. Okay, we got NH4, which has a +1 charge. We have phosphate, -3 charge. So what do we got to do with the NH4? Parentheses, we need 3 of them to match with the PO4. Table 7. What'd you call it? What'd you say? Table 1, chloric acid. HClO, 3. Very good, because she knows if it's an acid without hydro in front of it, it's chloric, which means it's chlorate, and so she matched it up. Table 5, middle table, calcium phosphate.
Is it CA3 parentheses PO4 parentheses 2?
CA3 PO4 2, he said with a question mark. Is he correct? Yes, he is. It's the crossover method. Table 4.
No. Oh, it's a 6. S3.
S3.
My bad.
Yep. Now, table 2, lead 2 oxide. What? PBO? Whoop. PBO, because in this case, lead is +2, oxygen -2. Table 8, lead 4 oxide. Got +4, oxygen -2. How many more oxygens you need? 1 more. So you get PbO2.